Evaluate 1/2 to the power of -3. This would be the same as 1 to the power of -3 over 2 to the power of -3. Recall, if you have a term with a negative exponent, we can change the negative exponents to positive exponents by using this property. A to the power of negative n is equal to 1 over a to the power of positive n. So in this case, also true that if you have 1 over b to the power of -n, you can make this positive by placing the b at the top of the fraction. So to make both exponents positive, we move 1 to the bottom of the fraction and 2 to the top of the fraction, so we would get 2 over 1 to the power of 3. So you notice that when we have a fraction like a over b to the power of -n, we can write this as a to the power of -n over b to the power of -n. And as you see, we have b goes to the top of the fraction to becomes positive for the exponents, and a goes to the bottom of the fraction. And as a result, we would get b over a to the power of n. So you look at this carefully, a over b to the power of -n is the same as b over a to the power of n. Looks like it's reciprocal. So in our example, 1 over 2 to the power of -3 becomes 2 over 1, which is a reciprocal of 1/2 to the power of 3. So this means simply 8. 2 to the power of 3 could be 8. And 1 to the power of 3 is 1, so the answer here is 8. Evaluate 1 over 3 to the power of -4. Recall, a to the power of -n is equal to 1 over a to the power of +n. Or if you have 1 over b to the power of -n, the same as b to the power of +n over 1. So in this case, to make this positive, we can write this as 3 to the power of +4 over 1. 3 to the power of 4, multiplying 3 by itself 4 times. 3 times 3 times 3 times 3, which is 9 times 9, 81. Evaluate 4 to the power of -3. Okay, recall a to the power of -n is the same as 1 over a to the power of +n. So here our base is 4, our exponent is -3. We can make the -3 to be +3 by writing this as 1 over 4 to the power of 3. So it would be 1 over 4 times 4 times 4, which is 64. Evaluate minus 4 minus times 4 plus x to the power of 0. So this is like a minus 1 times, in the parentheses, 4 plus x to the power of 0. Recall a to the power of 0 is equal to 1 as long as the exponent is 0, regardless of what we have for the base, the result would be equal to 1. So 4 plus x to the power of 0 would be equal to 1. Negative times 1 would be equal to minus 1. Evaluate. 7 to the power of 0 plus 4 to the power of minus 1 minus 2 to the power of minus 2 times 3. Recall a to the power of 0 is equal to 1. A to the power of minus n is equal to 1 over a to the power of plus n. So 7 to the power of 0 would be equal to 1. 4 to the power of minus 1 would be equal to 1 over 4 to the power of 1, or 1/4. 2 to the power of minus 2 would be 1 over 2 to the power of 2, positive 2, times 3. So we have 1 plus 1/4 minus 1/4 times 3. We have to follow the order of operation here. From left to right, we look for parentheses and exponents, which we don't have anymore here. We look for multiplication and division, which is the first multiplication is here. So this would be minus 1/4 times 3, which is equal to 3/4. So we have 1 plus 1/4 minus 3/4. So if I make all these like a fraction, the LCD in this case is 4. So I have to multiply the first fraction with 4 over 4. So I would have 4 over 4 plus 1 over 4 minus 3 over 4. I would get 4 plus 1 minus 3 over 4. 4 plus 1 is equal to 5. 5 minus 3 would be equal to 2. 2/4, and I reduce this to 1/2.